This video goes over two examples of how you can prove different properties of geometric figures using analytic geometry. So the first one that we're going to do is verify that a quadrilateral with vertices W, X, Y, and Z is a rhombus. So the first thing that I'm going to do is sketch my 4 points to visualize where the points are. So 1, 3, that would be W, that's in this quadrant. 4, 1, that would probably be over here. Y, 1, minus 1, and then Z, minus 2, and 1. That way I can see where all my points are, and what I'm going to check is if that shape is actually a rhombus. The first thing is that all 4 sides should be equal length. So we need to check that those 4 sides are going to be equal. So we've got, for side ZW, I'm going to use my length formula, which is the same as the distance formula. And I'm going to use my point. So this is Z and W. So I'm going to start with my x's. So I've got 1 minus 2 all squared. And then I'm going to add the y's. So 3 minus 1 all squared. And this is going to give me 1 plus 2 would be 3 squared plus 2 squared, which is 4. So this is going to give me 9 plus 4, which is going to be root 13. There's no need for me to simplify that because I know I'm just checking the length. If I get root 13 for the next one, I know that they're going to be the same. So now I'm going to do W and X. So I'm going to start with my X's squared and add my Y's squared. Here I get 4 minus 1 is 3 squared plus minus 2 squared. I've got 9 plus 4, so again, I'm going to get 13. Then I'm going to check my third side, XY. So my length is going to be 1 minus 4 squared plus minus 1 squared. So L is going to be equal to minus 3 squared plus minus 2 squared, which again gives me root 13. Things are looking good. The last one that I'm going to check is YZ. My length between those two is going to be minus 2 minus 1 all squared plus 1 minus 1 all squared, which again is minus 3 squared plus 2 squared, which is also going to give me root 13. So that means all the sides are equal. The next thing that I need to check is that the diagonals, so W and Y and Z and X, bisect at right angles. Okay, so that means I'm going to check 2 things. So I will do the right angles first. That means the slopes of those diagonals have to be negative reciprocals. So I'm going to find my slope between W and Y as Y2 minus Y1 over X2 minus X1, which is going to give me minus 4 over 0, so that is going to be undefined, which is okay. Then I need my slope of ZX. And then I'm going to have Y2 minus Y1 over X2 minus X1, which is going to give me 0. So they're negative reciprocals, which is good because they're opposites. And then I'm going to check and make sure that the midpoints are both the same, which means that they cut each other in half. So use capital M for midpoint, which matches the formula at the top. So my capital M between WY is going to be x1 plus x2 divided by 2, y1 plus y2 over 2, which is going to give me my midpoint of WY as 1. And we've got 3 plus minus 1 over 2, so 2 over 2, which is 1. And then we're going to find our midpoint between ZX, which is going to be minus 2 plus 4 over 2, and then 1 plus 1 over 2, which is also going to give us 1, 1. Therefore, WXYZ is a rhombus because it satisfies those 3 criteria. The second one that we're going to look at is a triangle, and this triangle has vertices P, Q, and R. So same thing, I'm just going to plot them here so I can visualize where they are. P, Q, and R. So here. And I want to verify that it is a right isosceles triangle. So the first thing that we're going to do is look at the lengths of the sides. 2 sides need to be equal. So let's check our P first. We're going to use our length formula as listed on the top, going between R and P. We've got x2 minus x1 squared plus y2 minus y1 squared, which is going to give us minus 8 squared plus minus 4 squared, which is 64 plus 16, which is root, not quite root 100 here. So 64 plus 16 is going to give us root 80, which is fine. Again, we can just leave it as is. Next one we're going to check is our Q. So we've got our length is going to be x2 minus x1, y2 minus y1, which is going to give us minus 12 squared. Plus plus 4 squared, which is going to be 144 plus 16, which I already can see is different, which is root 160. And then the last one we're going to check is PQ. So we're looking at our length formula again. We have got x2 minus x1 squared plus y2 minus y1 squared, which is going to give me 4 squared plus minus 8 squared, which is going to give us that root 80. So we've checked that 2 sides are equal. The next thing that we need to do is verify that there is one right angle. Now from my sketch, I know which 2 sides that I'm going to check. I'm going to check if RP and PQ are perpendicular. So that means that I need my slope for RP, which would be y2 minus y1 all over x2 minus x1, which is going to give me my slope for that side of the triangle. So I would have 4 over 8, which would give me 1/2. And then I need my slope between P and Q, which is going to be y2 minus y1 over x2 minus x1. So my slope between P and Q would be minus 8 over 4, which is minus 2. So since there are two equal sides and the slope of RP is perpendicular to the slope of PQ. PQR is an isosceles right triangle because it satisfies those two criteria.